Alrighty, let's go over homework number 15. This is a washing machine. So what does that really mean? A washing machine is just a giant state machine. This was very open-ended, so the way I chose to tackle it was to have a running and a stopped state, and then to have a mode state. So light, medium, heavy, and delicates. Classic washing machine settings. So we're using enums because they make the states very clear, and you could see how this logic could be expanded into more detailed feature set in the future. So we have the clock, because a lot of these operations are going to happen on the clock. We have our essential button to be on and off, basically. We have switches. We're only using 2 switches, actually, because we have 4 modes. So it's a 4-bit mode select. And then we have our LED array, and this we're just going to use this to showcase the speed at which things are happening. It's a little misleading because my delicates are actually going to blink faster than my heavy, but it'll make sense. So we have our enums declared here, and then we actually assign our enums to a signal and give it a default state. So it starts stopped and it starts in the light mode. This wouldn't matter anyways because it's determined by the switch, the mode is, but I assigned it just in case. State select is whether or not this is a boolean that the button flops in order to change the state. Mode select is the vector. And then we have a count and a timer integer in order to hold the values that we use to blink the LEDs. And then we have an LED state, which again we flop in order to blink the LEDs. And then we have a few constants that we use to assign the blink rate. So as you can see, as we go up through the modes from mode 0 to mode 3, we get progressively faster. So we assign the mode select, and then the way I chose to do this was as a chain of processes. This is a little bit controversial when it comes to a finite state machine. It's safer if you have everything within one giant process, but it was easier for me to think through the problem this way, so I went for it. So let's walk through it real quick. So each process I made responsible for really only one thing. So this first process triggers on the mode select, and it just maps the mode select pin to one of the enums. It switches between light, medium, heavy, and delicate. That's all that does. Next, we trigger on the enum. Whenever one of these enum changes, we change the timer variable to that of the constant that coincides with it. Then we have a process, our first process on the clock. So it checks the previous state of the button and sets it to 0. And then if the rising edge of the clock happens, this is classic on the clock trigger, then if the previous state of the button was 0 and the current state of the button was 1, then it flops the state select. So what does this mean? This makes sure that when you press down the button, it only triggers a single time instead of happening every time the clock triggers. And this is how we turn it on and off. Next, we have the state select. This is what the button is actually flopping. And so if this is a boolean that I then map to the 2 enums. Again, this is not necessary. You could do this whole thing with just booleans and switches and no enums, but enums just make it easier to understand what's happening, because then we get to write nice states like this, or if the state is running, then we count, and the count is greater than or equal to the timer, then we flop the LED state, and then we reset the count to 0. So this running here is nice, right? And then if not, then we turn the LEDs off because the machine is off. Lastly, we just process the LED state. If it's true, then all the LEDs are high, and if it's false, then all the LEDs are off. So this chain of processes works, although it's not necessarily best practice, but it works for this. So let's take a look at it. So right now, it's in mode 1, which is light. So if I turn it on, the LEDs are going to pulse once every second. Now I can switch modes on the fly. So let's go to medium. It's faster. And then light, heavy. And then delicates. and then I can turn it off, and turn it back on, and yeah, the on and off state are separate from the speed of the cycle. So I think this is a fair enough representation of the basic logic of a washing machine. This doesn't have any timers or like ending, but that could easily be expanded because we have these clearly mapped enums that we're working with.